Hello, calculus fans. All right, let's move on to concavity. We talked about that before, so let's see if we can remember the definition of concavity. So we said that a function, or its graph, is concave up on an interval if f prime of x is an increasing function on that interval. It's concave down on that interval if f prime of x is decreasing on that interval. Now remember that we're not saying that the original function is an increasing function. We're saying that f prime is increasing or f prime is decreasing. Now we've got some other characterizations. For instance, we talked about how if the tangent line is, at least locally, below the curve, then the curve is concave up. Now if the tangent line lies above the curve, at least locally, then we'll say that the curve is concave down. Remember that we also said that whenever a curve changes concavity, it does so at an inflection point. At the beginning of this section, we talked about the increasing-decreasing test, and in the same sort of way, we have a test for concavity. So we've actually talked about the concavity test, essentially. It says that if the second derivative is positive on an interval, then f of x is concave up on that interval. And if f double prime is negative on an interval, then it's concave down. So the second derivative is what's telling us about concavity. Positive second derivative, concave up. Negative second derivative, concave down. Now, as it turns out, we can actually use concavity to check for local extrema. And so now this is following up on our description of the first derivative test. Here what we have is the second derivative test. So this says that suppose we have a second derivative which is continuous near a point x equals c. So it says that if the first derivative is 0, making it a critical point, and the second derivative is positive, then what we have is a local minimum, because it's concave up. If the first derivative is 0, and the second derivative is negative, then we have a local maximum. On the other hand, if the first derivative is 0 and the second derivative is also 0, then the test is inconclusive. Now it's important to note that in this third case, our test being inconclusive means that anything is still possible. There may still be a local maximum or a local minimum, or there may be no local extremum there at all. Inconclusive literally means we don't know. There's no conclusion that we can reach. So even in the event that the second derivative test is inconclusive, we can always fall back on the first derivative test. Okay, that's all for now.